The base of a solid is a disk x squared plus y squared is less than or equal to 4. The cross sections by planes perpendicular to the y-axis are isosceles right triangles with one leg in the disk. Find the volume. Let's start by sketching a picture. So we're going to tilt the axes a little bit here. Don't tilt them too much. That's just so we can see them. We really don't have to make it dotted. Now, what is this shape? This is a circle, and by saying less than or equal to, we want the interior part of it. So we'll sketch a circle. It's a little warped there at the end, but it's okay. Now we know that these numbers will be 2 or negative 2 and positive 2. Now we need to sketch an element. Now our y-axis is here. We are going to go perpendicular to it. So just like area, let's start off with a rectangle. And now it says that they are isosceles right triangles with one leg in the disk. So this piece right here represents one leg. Now what's the thickness of this? It's along the y-axis, so this is going to be delta y. From here, this is going to have to come up. And technically, if we want to make it nice, we could say that this inside part is going to be dotted. So something roughly equivalent to there. And then we'll connect it, the ends of them. And if we really wanted to be fancy, we could make this one dotted too. And we have an isosceles right triangle. We have our right angle right here. Now what we need to do is figure out what's going on with this. We have x squared plus y squared equals 4. Since we have a delta y integral, everything needs to be in terms of y. So we have x squared equals 4 minus y squared, or x equals plus or minus the square root of 4 minus y squared. Now we can treat this one a couple of ways because there's symmetry in here. This positive side, the right side, will be the positive side and the left side will be the negative. One way to do it is to say that it's going to be the right minus the left, and the right will be positive 4 minus y squared minus the left, which is negative 4 minus y squared, and we'll get 2 times the quantity of 4 minus y squared. Another way to do it is to realize, due to symmetry, these two segments are equal, and if we're going from 0 to square root of 4 minus y squared, then it's going to double it for the whole length. We have the area of our triangle is going to be 1/2 base times height. Our base and height are both going to be the same thing. They will be 2 times the square root of 4 minus y squared. And then for the height, 2 minus the quantity of 4 minus y squared. We have 1/2 of 2 and 2, so we'll be left with 2. And then the square root of 4 minus y squared times 4 minus y squared will just give us 4 minus y squared. So now we could say the integral from our lower limit, we're going to go along the y-axis, remember, since our integral is going to be a dy, we'll have negative 2 to 2 of 2 times 4 minus y squared times our thickness of dy. Now another thing that could be nice with this one is to realize we have symmetry going from negative 2 to 2. From negative 2 to 0 is going to be the exact same thing as from 0 to 2. So what we can do is, I'll take out this first 2, and then instead of going from -2 to 2, we'll go 0 to 2, but we'll double this integral value. And then we can just have 4 minus y squared dy. By doing it like this, we'll have a little simpler calculations. So we have just 4, and now we just find the antiderivative, 4y minus y cubed over 3, evaluated from 0 to 2, and I'll make that look the same. Plug in our 2, so we have, I was thinking about the next one, and even that wouldn't be right. So 2 would be 8 minus 8/3 minus, now since we have 0 there, it's more convenient to evaluate. And now this will be 24 over 3, so that'll be 4 times 16/3, which will be 64/3, and that'll be units cubed. Let's take a look at another problem here. Find the volume of the solid formed by revolving the region formed by y equals 0 and y equals sine x when 0 is less than or equal to x, which is less than or equal to pi, is revolved about the x-axis. Now this is just a straight revolving problem, so we don't need to tilt our axes. It's only on those perpendicular cross sections where we want to do that. And I will just draw some sketch of sine x. We're going from 0 to pi, and I can just label that 1 where the max is. Now remember, for this one, what we're going to do is we start with our original graph, then we are going to copy it down on the other side of our axis of revolution. We should mark this. We are revolving it around the x-axis there. Now we're going to draw one element. So start off with your rectangle, label it as delta x, and then we will sketch an ellipse there. And on the back side, since we won't be able to see it, we put it as dotted. Let's see, what do we have now? We have volume. The volume of one disk, the volume of a disk will be this area. Well, what's that area? It's going to be the area of the face of the disk times the thickness of the disk. So that area is a circle when it's revolved around the x-axis there. The area of the circle will be pi times the radius squared, and then our thickness will be delta x. What is our radius? That's a distance from our axis of rotation to the curve, or in this case from the x-axis all the way up to the curve. That curve value is sine x, so this will be pi times sine squared of x times dx. What do we want to do with that? We want to sum them all up from 0 to pi, and since pi sine squared x dx, we can take out that pi since it's a constant, and remember our identity for sine squared of x. That would be 1 minus cosine 2x over 2 dx. Integrate each one of those separately. We'd have 1/2 x minus 1/2 of the antiderivative of cosine x would be sine, or cosine 2x would be sine 2x over 2. We have pi, and we'll go from 0 to pi. We could take out this 1/2 there and say pi over 2 minus sine 2x over 2. It's not essential. So we have pi over 2, and then pi minus the sine of 2 pi, and the sine of 2 pi would be 0, minus 0 minus 0. Remember to always plug in that 0, especially when you have a trig function, because the answer will not always be 0. And that will give us pi squared over 2 cubic units. Now, in this particular problem, we could have gone 0 to pi over 2 and doubled it. But this calculation was pretty easy to go to pi. See if I can squeeze in one more. How would you find the volume if you rotated about the y-axis this time? So I just drew some curve here. We're going to rotate around the y-axis, so let's copy it about there. And then we're going to connect this with an ellipse. We're going to draw our element. Our element's thickness is on the y-axis, so it would be delta y. And when it's a disk, and the last one I drew it nicely, what you could do is just draw one disk. And that would be sufficient for this. And if you wanted to have it nice, it would end up coming in. You could have a little thickness on there, and you could do it like that. How would I find the volume this time? Well, let's assume this value down here is C and it goes up to D. We're going to be summing up along the y-axis, and then when we take the limit as the thickness goes to 0, we'll get our integral, and it will go from C to D, the lower y number to the upper y number, times pi, or of pi times the radius squared, and then this would be dy. And what is the radius? The radius is this x value, and we can call that f of y. So it's going to be a function of y. Everything in this integral has to be in terms of y. Let's see if we can do an example of that. Y equals x squared, which is basically what this curve is, the y-axis, and y equals 3. And we will revolve this around the y-axis. Find the volume. So what do we need to do? We need to get this equation, y equals x squared, in terms of y. We need to solve for it. We get the plus or minus the square root of y. What is this side? This side will be the positive one, so we don't want that negative. So we can look and say the volume. What's our lower limit? Well, the y-axis is going to be hitting this curve y equals x squared at this point. That'll be at 0. The upper value is going to stop at 3 pi times the square root of y, quantity squared, dy. Take out the pi, and we have the integral from 0 to 3 of y dy. So we have y pi times y squared over 2 from 0 to 3. And we get pi times 9 over 2 minus 0, or in other words, 9 pi over 2 cubic units. And there you can see that there. So really there's not a whole lot of difference between if you're going to sum up along the x-axis or y-axis. When we're summing up along the x-axis, as in number 2, everything had to be in terms of x. If we're going to sum up along the y-axis, everything has to be in terms of y. So in other words, we need to solve our equation for x so we can get it in terms of y. We're looking at this horizontal distance here, this radius, is going to be the difference in x numbers. And that is it.